Hi everyone, we're going to determine whether Rolle's theorem applies on the closed interval AB, and if so, find all the values of C such that the derivative of f at C equals 0. And there's your theorem, and this is part 4, so I'm not going to read that. So these are our two problems, our closed intervals. They're the trig functions, sine and cosine. So you know what the graphs look like, and you can probably know that it does apply. So we just have to kind of show what it does. When I plug in 0 and I plug in 2 pi, I get 0. Therefore, f is continuous on our closed interval. All right, and it's also going to be differentiable on our open interval. So we have to take the derivative of sine, which is cosine of x, and we want to set this to 0. So cosine of pi over 2 equals 0, and cosine of 3 pi over 2 equals 0. Therefore, my C values are pi over 2 and 3 pi over 2. And for cosine, we have f of x equals cosine of x. We're looking on the closed interval 0, 2 pi. And I'm going to evaluate 0 and 2 pi. And actually, these are the same coterminal points. That equals 1. So therefore, f is continuous. On this closed interval, and f is differentiable on the open interval, which would be 0, 0, 2 pi. So we've got to find our C. So I'm going to take the derivative of cosine, which is negative sine of x, set this to 0. So we're going to see that sine between 0 and 2 pi, sine would have to be pi. So x equals pi, therefore my C value is pi. And you might notice that sine of 0 is also 0. However, remember this is our open interval. So we can't use that because that's excluding the 0 and the 2 pi. Okay, thank you. Have a nice day. Bye-bye.